Dear students, welcome back. This is Dr. Biju Vasudevan. This video is for Class 1 Math 111 for week 10. Actually, this is week 12 running, but I have uploaded some popular YouTube videos for week 10 that covers chapters 3.3 and 3.4. But some of our students have claimed through WhatsApp and mail that they need videos from my side. So I decided to come up with another video for week number 10. First, this part deals with the derivative of exponential and inverse trigonometric functions. Okay. In this section, we will see how derivative of a one-to-one function can be used to get the derivative of its inverse function. Okay, have you seen what is one-to-one function? The function which is one-to-one should satisfy a horizontal line test, isn't it? That is what you mean by horizontal line test. This is xy plane and there is a curve going like this. If this is f of x, horizontal line should intersect this curve f of x exactly once. If the curve is like this and it intersects more than one places, then it's not one-to-one. So this is the concept of one-to-one, isn't it? Now we are going to find the derivative of the inverse function by using the derivative the function for one-to-one kind of functions, isn't it? So okay, let's see it here. Okay. Suppose that the domain of a function f is an open interval on which f prime is either positive or negative. It means that if the f prime is positive, it means the slope is positive, isn't it? So it will be like this. So it means that the function is increasing. When positive first derivative is greater than 0, it means the function is increasing. So slope will be positive. If the slope is negative, it means that function is decreasing. Slope will be negative. It will be negative like this. The slope of these tangent lines will be negative. So when the slope is positive, it is increasing. Slope is negative, it is decreasing. So it should be either increasing or decreasing function. Then we can say it is one-to-one. But if the function increases and after some point it decreases, then it's not one-to-one. It's not a one-to-one. So remember, if in this case the function is one-to-one, it means that there is an inverse possible, and f prime of x is differentiable in the range of f. The range of f will be the domain of f inverse. So the formula for the derivation is given by this one. So what's the meaning? So f inverse, you are looking for the derivative of f inverse, which is 1 over the derivative of the original function and replace the variable x by f inverse of x. The idea here it is, if I give you y is equal to sine inverse x, how to find the derivative of y? dy by dx. Here we are going to find a formula, isn't it? So what they are suggesting here, we can write from this one, we can write sine y is equal to x, isn't it? And then from this one we can write, this is a different version of the same formula. This is 1 over dx over dy, isn't it? This formula can be interpreted this way. Dy by dx is 1 over dx over dy, isn't it? So I am finding dx over dy from this one. When you find dx over dy, when you differentiate right side, it is dx over dy. Left side it will be cosine y. So here we are writing it is 1 over cosine y. And we remember cosine y is 1 over square root of 1 minus sine square y. But sine y is x, so the answer is 1 over root of 1 minus x squared. This way this formula will be used, isn't it? So here the derivative, the denominator should not be 0. So this formula of derivation of sine inverse we have derived it. Here it is derivation of sine inverse x with respect to x is 1 over square root of 1 minus x square. So this is the formula we are going to use. This can be expressed in different way. That is, the derivation has been given here. What is it? The derivation of this formula. Y is y is f inverse of x. So x is f of y. So when you differentiate this one and this one, this is 1, this one, x is, when you differentiate x is 1, when you differentiate f of y, it will be f prime of y and dy by dx by chain rule. Therefore dy by dx is 1 over f prime of y. We can call it dx by dy. That's, and now replace the variable and you get this one. So this is the form, actually. It's just the form of the formula. Dy by dx is 1 over dx by dy, and then replace the variables. Obviously we know what do you mean by inverse of the function. This is the function f of x given in pink color, isn't it? And then its inverse will be a reflection about y is equal to x in this side. This is the inverse of the function. So its slope at the point x equal to 2 here. This is the tangent line at x equal to 2. The slope is found here, f prime of 2. The inverse of this slope will be the slope of this one. So 1 over f prime of 2. This is when y is 2. Here when x is 2, when it is y is 2, you will find a slope here. So if the slope here, if it is 1 by 4, the slope here will be 4 at y is equal to 2. So that's it. Now, some important formulas of derivatives of exponentials and inverses. We have derived sine inverse x. Derivative of sine inverse u. Now we can easily expand. It is for sine inverse x. What do you do? Root 1 over root of 1 minus u square, and differentiate u by chain rule. That is du over dx. That is it. So in this similar way, what I have done for sine, you can try for cosine. Okay, now we know derivation of exponential is the same. E power x will remain e power x. Even if you integrate or differentiate, the exponential will be exponential. Okay? So when x is replaced by another function u, you use chain rule. E power u will remain e power u, and then derivate this u, du by dx. That's here. Let's discuss about exponential, other exponents, b power x. Isn't it? So if for this formula we are looking for the first one now, we take y is equal to b power x, and then take ln on both the sides. Ln y is equal to ln b power x. So we can write ln y is equal to x times ln b. So differentiate both the sides. You will get 1 over y into dy by dx the left side by using chain rule. The right side, x is the only variable, it will be 1, and constant ln b remains. So dy by dx is equal to ln b, the constant, times y. What is y? Y is given function b power x. So the answer dy by dx is ln b times b raised to x. So that is for this formula. So if b is replaced by e, ln e will be 1, so you will get e power x directly. If b is replaced by e, in this formula it will be ln e will be 1 and e power x. So it will be giving you this formula. Now the same formula can be extended here. If x is replaced by another function u, which is a function of x, then repeat this term, differentiate b power x, b power u ln b, and then differentiate u by chain rule, du by dx. That is this formula. So remember these basic formulas for b power x, any base b. When base is e, it is different. B power x, b power u, and e power u. There are 4 formulas for exponentials and 2 formula for sine and cosine inverse. Here there are other set of formulas. We can still verify one of these formulas, and let me take tan inverse. Our function y is tan inverse x. We have to find derivative of y, dy by dx, which is derivative of tan inverse x with respect to x. This is what our question. And by the first rule, we know that this is 1 over dx by dy, isn't it? So first let's find what is x from this one. This is tan y. When you multiply when you take tan on both sides, tan is equal to x. Tan y is equal to x. So when you differentiate x with respect to y from here, what do you get? Differentiate x with respect to y. So dx by dy is equal to secant square y. So here the answer dy by dx is 1 over secant square y. But we know secant square y can be written as 1 over 1 plus tan square y. But what is tan y? Tan y is x. Tan y is x. So the answer here it is 1 over 1 plus x square. You see? Tan inverse u. When the x is replaced by another function, function u, it will be 1 over 1 plus u square by using this formula. And then differentiate u using chain rule. That is it. So you can try the similar technique for cotangent, secant and cosecant. We don't need to prove these formulas. We need to use them coming from problems. So remember, this is for tan inverse. The same with the negative sign for cotangent inverse. If you derive the formula for secant inverse, the same with the negative sign for cosecant inverse. Okay, so that's it. Let's use them in the coming problems. The first problem, find f prime, f inverse, derivative of the f inverse using formula to the formula that we have seen. The formula, quite simply, it is dy by dx is equal to 1 over dx by dy, isn't it? Let's remember this one. What we are going to do here, it is f of x, that is our y is given as 2 over x plus 3. It's inverse we are looking for, actually. It's inverse we are looking for. Okay, let's do it. Then dx by, then we will revert it. Dx by dy is equal to 1 over dy by dx. That's it. So y, when you find dy by dx, it will be minus 2x plus 3 whole square. So its inverse is nothing but given here. Multiply, cross multiply this one. X plus 3 times y is equal to 2. X plus 3 is equal to y, 2 over y. X is equal to 2 over y minus 3. This is actually inverse function of this one. You can write the function f inverse of x is 2 over x minus 3, just to replace the variable by x, to say everything is in x. That's it. So we need to write this one. We need to find dx by dy. Actually, this is our derivative function x. So when you differentiate x with respect to y, that is inverse. So, and then replace the variable. That's all. 1 over dy by dx by this formula. This is invert this given time. This is x plus 3 whole square in the numerator divided by negative 2. Okay, now replace the x value by using this one, 2 over y minus 3. That is 2 over y minus 3. Remember, we can write 2 over y as 2 over x. Just replace a new variable. That's it. Minus 3 plus 3 whole square divided by minus 2. And when you simplify this one, negative 3 positive 3 will be 0. Instead of y, we use a new variable x. So it is 2 over x whole square into 1 over negative 2. You get negative 2 over x square by formula 2. And we can verify this one by differentiating f inverse directly. F inverse is given here. This formula is this equation number 1. This is equation number 1. This is equation number 2. This equation number 2 is the inverse function. When you differentiate this one with respect to y, you will get the direct derivation. Minus, what is it? Dx by dy will be minus 2 over y square 0, minus 2 over y square, that's the answer. Instead of y we have a new variable x, that's it. So by direct differentiation we can verify it. If you find inverse and verify. The next problem, determine whether the function is 1 to 1 by examining the sign of first derivative. Okay, mostly when there are even powers, it cannot be 1 to 1, it will go like a parabola. Let's try. What is the first derivative of this one? F prime of x, 2x plus 8, and we want some interval. Let this f prime, because let this f prime of x equal to 0 to get some intervals. 2x plus 8 is 0, x 2x is equal to negative 8, x is equal to negative 4. Why should I find negative 4? So the point is, the interval in the real line from negative infinity to positive infinity separated into two parts, minus infinity to minus 4 and minus 4 to plus infinity. There are two intervals, this interval 2, this interval 1. In this interval, find the value of f prime of x. Take some value between lesser than, which is lesser than negative 4 and within negative infinity, isn't it? So we can take negative 5. What is it? Negative 5 in the first derivative. 2 into negative 5 plus 8. Are you getting negative? So are you getting negative? Yes, you are getting negative, negative 10 plus 2 negative. So this is decreasing, the function is decreasing in the interval. In the second case, take 0. Actually 0 is in this interval. So f prime of 0 is 2 times 0, 0 plus 8. This is positive. So this function is increasing. See, in the natural domain of this natural domain of this function is negative infinity to positive infinity. In this domain, the function is decreasing and of course increasing. It will have a parabolic shape. So horizontal line test will fail. Obviously, this is not 1 to 1. You try the other problems, the explanation, other problems. You can try. I will give you one. Try B, which is similar to A. I will solve one more problem. C or D. Let me go with the C. C. What is f prime for C? Which is 2. When you differentiate sin, it will be cosine x, isn't it? See, for no need to find the interval, because throughout the interval you can say for any value of x, cosine is either positive or negative 1. Maximum, isn't it? Maximum. The range of cosine x is positive or minus. So this value of f prime x plus or minus 1, 2 plus or minus 1, because cosine, the range is plus 1 and minus 1, plus or minus 1. The value of cosine, the output, when you give input x, the output of cosine will be maximum positive or minimum negative 1. All the values of cosine will be lying between this one, isn't it? So 2 plus 1 is 3, or 2 minus 1 is 1. Anyway, there is no negative value. So f prime is continuously increasing throughout the interval negative infinity to positive infinity, isn't it? So this is continuously increasing, therefore this is 1 to 1. The function should either increase or decrease. It should not be both. That's it. Try this one. So f prime should be either positive or negative in the given interval, in the given domain. It should not be both. Fine. Let's go with the answers have been given here. Next is a similar type problem. You try this one, the same type problem that we solved, the way we found sine inverse and cosine, derivative of sine inverse, cosine inverse, and the first problem also. You can try this one yourself. Now we are going to find the differentiation of some problems given here. Okay, let me give you an idea. Let me solve problem number 17 first. Use product rule. Use product rule for 17. You are not finding the inverse of the derivative of the inverse. You are directly differentiating the exponential and that's all. Only exponential functions here, right? Okay, natural logarithm of force. Okay, dy by dx for the first one is y prime. You can use product rule. Keep x cube, differentiate e power x, it will be e power x. Now keep e power x, differentiate x cube, it will be 3x square. That is it. That is it. And now let's take 21. Okay, let's try 21. 20 is quite simple. Use chain rule. Differentiate sine, it will be cosine e power x, and go inside differentiate e power x, it will be e power x. Just chain rule. Now let me try 21. Mm, 21. So y prime is e power x. Whenever you try e power, whatever the power remains. So when we differentiate e power x tan x, e power x tan x, and then go to the power, differentiate by using product rule. Keep x, differentiate tan, it will be secant square x, and then keep tan, differentiate x, it will be 1. That's it. That's it. Okay, now we can simplify what we have done differentiation. That's it. Now 22, use quotient rule, u over v. U over v. Try yourself. You want me to try yourself. What about 24? 24, exp stands for exponential. This is nothing but e power 1 plus 5x cubed to the power half, because under square root. So when you differentiate this one, e power 1 plus 5x cubed to the power half will remain as it is, when you, because the e power u will be e power u, and then u should be differentiated this one. Half 1 plus 5x cubed to the power minus half, and inner term 0 plus 15x square. That's it. Simplify this one. The numerator you will get 15x square into e power 1 plus 5x cubed to the power half, and the denominator you will get 2 into square root of 1 plus 5x cubed. That's it. So try the last one yourself. You want me to try? Y prime for 26. It is, when you differentiate ln, it will be 1 over cosine e power x, and then differentiate cosine and e power using product rule. No, it is one function, cosine of e power x. Okay, this is one term, not cosine x into e power x. It is cosine of e power x. So when you differentiate cosine, it will be negative sine e power x, and then again differentiate e power x, it will be e power x. So the answer is negative e power x, sine and cosine will be 10. Negative e power x at the top, and sine over cosine will be tan e power x. See, the theta is replaced by e power x. Remember that, isn't it? That's it. Let's see some other problems. These are the solutions of those problems. Now find dy by first derivation df dash of x by formula 7, and then by logarithmic differentiation. Actually by formula 7, what do you mean by formula 7? Then if there is a b power x, the answer is the derivation of the b power x with respect to dx is what? ln b into b power x. We have seen this one. Go back to the formula collection. Here ln b power x, isn't it? So that's what I asked to find. So directly use formula 7 or by logarithmic differentiation. Logarithmic. So you can use the direct formula. I use the method logarithmic differentiation. For 27, yeah, I'm trying 27. How to do it? Y is equal to 2 power x. Let. And then take ln on both sides. Ln y is equal to ln 2 power x. That's the method I use to derive this formula, isn't it? So when you so you can write this one. Ln y is x using the power rule of natural logarithm, x into ln 2. Now differentiate both the sides. This is 1 over y into y prime. The right side x will be variable 1, ln 2 is constant, and y prime is ln 2 times y. So which is ln 2y is chosen, given here, it's 2 power x, 2 to the power x. So this is different. So the answer is dy by dx is 2 power x into ln 2. Directly using formula, I will get you the same. ln b is 2 and 2 power x. And let's try pi power x, 30. Y is equal to pi tan x. Pi tan x. So we want differentiation direct formula. You can use b power u. The formula for y is b power u. When you differentiate, the same with the du by dx. Just the formula, isn't it? Use the direct formula yourself, and I use logarithmic differentiation. How to use logarithm to find the differentiation? Ln, you can directly use the formula also, isn't it? If you understand the formula, what is it? When there is a b by u, ln b, b power u, and du by dx. This is the answer. So here, so you can directly write ln pi and pi power pi tan x, and then differentiate pi tan x. It will be pi into secant square x. Actually this is x and not pi, so I will rewrite the question again. This is not x and pi, actually this is x. It was glaring actually. I couldn't see. So this is x. So let me solve it again right from the beginning. Y is equal to pi to the power x tan x. Now direct formula, you should remember what is y prime in this case. Ln b power u and du by dx. Ln b is pi, ln pi, and the same function pi power x tan x, and then differentiate x tan x by product rule. That is it. Directly you can do that by using formula, but I am using logarithmic differentiation. Now ln y is equal to ln pi x tan x, and it will be x tan x into ln pi ln y. Differentiate with respect to x on both sides. So this is 1 over y prime. The constant ln pi should be kept as it is. Differentiate x tan x by using product rule. Keep x, differentiate tan x, it will be secant square x. Keep tan x, differentiate x, it will be 1. So y prime is, this y goes on the right side. Y ln pi x secant square x plus tan x, and replace the value of y. What is it? Which is given here. So pi to the power x tan x and ln pi into x secant square x plus tan x. That's the end of this problem. We are supposed to use logarithmic differentiation method to solve these problems. Okay, I'll solve only one problem. Rest is left to you, isn't it? 31 I will take ln on both sides. Whenever you are using logarithm differentiation, that's the same method we used for the previous problems. Ln y is equal to, so So this power will come in front ln x. I skipped one step, isn't it? Ln x into ln x cube minus 2x. Taking ln on both sides and using power rule of ln, you will get this one. When you differentiate, it will be 1 over y prime, 1 over y prime. The right side. Product rule should be used. Both are ln functions with variable x, isn't it? Product rule. So keep ln x, differentiate the second one. It will be 1 over x cube minus 2x, and then chain rule gives you 3x square minus 2. Now keep this ln x cube minus 2x, differentiate ln x, it will be 1 over x. And then the last step is y prime. This y should go here, isn't it? Y ln x 3x square minus 2 divided by x cube minus 2x plus ln x cube minus 2x divided by x, and you can replace the value of y from the given function. That will be the end. Y x cube minus 2x power ln x, and then repeat all these terms. That's it. For these two problems, use any method to find differentiables. See, for this one, direct product rule you can use. For this one, product rule and the formula product rule. When you differentiate this one, use the formula for b power x. Okay, here by a logarithmic differentiation you can try. I leave this problem to you. Now we are finding the derivative of the inverse functions, sine inverse, cosine inverse, tan inverse, all these things, and we have seen the formula for derivative of sine inverse. What is it? 1 over root of 1 minus x square. And this way, if you write for cosine inverse, it will be negative 1 over root of 1 minus x square. So let's use that one. What do you get? For 45, y prime is 1 over square root of 1 minus x square for sine inverse, and then differentiate this term by using chain rule, isn't it? Minus 1 over x square. That's it. You can stop here. For 46, what you do? So it will be, you consider this is u. This is given as y is cosine inverse u. Use the formula. So y prime is 1 over negative 1 over root of 1 minus u square, 1 minus u square into derivative of u. When you differentiate cosine, it will be minus sin x. Minus sin x. So this will be positive sin x, the numerator, divided by 1 minus u square. U is, what is u? Cosine. 1 minus u square, 1 minus sin square root of 1 minus cosine square, which is again sin x, but here plus or minus sin, isn't it? A positive square root. Okay, it's depending upon this positive or negative, you will get plus or minus 1 as an answer. Okay. That's 40, 50. And let's try it for 50. Problem number 50. We can write y is tan inverse x whole inverse. Therefore, the y prime is negative 1 power rule we are using. Tan inverse x to the power minus 2, and then differentiate tan inverse, it will be it will be 1 over 1 plus x square. Therefore we can write a negative 1 over 1 plus x square into tan inverse x to the power minus 2. That's it. Try this problem yourself. Product rule and then power rule. You can try this one. That's it. There's no other problem. The next chapter is dealing with the related rate. If possible, I will upload the video for related rate as well as soon as possible. Thank you very much. Thank you very much.